So at the thin segment of ascending, they're going to be a passive transport of sodium chloride. And at the thick segment of ascending limb, they're going to be an active transport of sodium chloride. So in terms of the concentration of the solutes, at the lower arm of the loop of Henle, it has high concentration of the solutes, about 1,200. As it goes up to the ascending limb, the concentration of the solutes decrease and there's more water compared to the salt because of the reabsorption of sodium chloride that occurs at the thin and thick segment of ascending limb. Okay, the one that shows here is the reabsorption of ions, water at the proximal tubule and the distal tubule. But at proximal tubule, about 80% of reabsorption takes place, and you have to take note on the adaptive structures of the proximal tubule. For example, abundant mitochondria to help the active transport, to help provide the energy for the active transport, and another one, microvilli, to increase the surface area for reabsorption to take place. So those are the adaptive structures at the proximal tubule. For distal, apart from reabsorption, there's also secretion process that takes place. Okay, another thing that you have to remember that for nephron, it starts with the glomerulus, proximal, loop of Henle, and up until distal tubule. Collecting duct is not part of the nephron. But at the collecting duct, there's also reabsorption occurs, reabsorption of sodium chloride by active transport and reabsorption of urea and water by passive. So of course, water moved by osmosis and the urine will be formed and excreted here.